because it starts getting, the closer it is, the more this is a factor. So if you ignore them really close to each other, then the crude approximation of its point charge at the center becomes more valid.
So what chapter would you say this is?
Chapter 23. All right, other questions? Let's talk electric dipoles. An electric dipole is something that is overall neutral, but polarized. So if I have a charge Q here, I'd have a charge negative Q here, and that they are a fixed distance apart, we'll just call it S. You can treat a water molecule as a polarized molecule. It's an electric dipole, and there are a lot of molecules that's the most common one, obviously. So if I am a very far distance away from this, so let's say I have this neutral object here, and I have a charge, a positive charge, on the other side of campus, it's going to look like a single neutral object. But the closer I get to it, the more I see that the charges are separated. And so whatever formula I come up with here for how another charge will influence it, I should be able to check it by saying, well, if I go an infinite distance away, what happens to my formula? So, for example, I've got my Q and negative Q here, a distance S apart, and then at some distance L, I have a test charge, Q, little q. And what I want to know is, what's the net force on little q? The way you deal with it is you look at the chart, the force from big Q, and then the force from negative Q, add them together. So what is the direction of the force on little q from big Q? Your thinking is almost there. On little q. Yeah. So it's going to be that way. So this is the force on little q from big Q. And what is the direction of the force on little q from negative q? Not if I'm interpreting your hand gesture, Chris.
Negative q on little q? Or
The force on little q from negative q.
up to the right?
And Paul says the opposite. Sorry. Felt like I just met you. Patrick says the opposite. So we have one going this way and one going that way. Change your mind? Yeah. Without any other information, assume that Q is positive, and so therefore it would be attracted. So the force on little q from negative q. Now, the distance from each of those charges to little q is going to be the same. The magnitude of the distance, I guess that's just distance. And so the net force will be down. Now I know that's not satisfying, so let's quickly crank through the math. So that over dinner, if you're having dinner with someone, you can regale them with the tales of how wonderful it was to come up with an answer. So this distance right here, I know that this is L, this is 1/2 of S. The magnitude of that force, actually let's put a little theta right there. This is little r, so the magnitude of that force going in that direction, and that angle is theta. This would be K, big Q, little q, over r squared. The magnitude of this force would be the same, K, E, big Q, little q, over r squared. Notice the minus sign is not there because the minus sign is telling us the direction of the force. Once we've established the direction of the force, I'm not worried about it. You let the arrows indicate that. I know that the horizontal components will cancel out by symmetry, and so I just have the downward force. Let's assume up is positive, and so I have my total force on little q, Ke, big Q, little q over r squared, sine of theta, times 2. Well, sine of theta is opposite over hypotenuse. So that's 1, so this becomes 2 Ke, big Q, little q, over r squared. Well, actually, we know what r is also. That's L squared plus 1/2 S squared, times the sine of theta, which is 1/2 S over r, which is, well, the half of the 2 cancel out, so I'm left with K, E, Q, big Q, little q, S over L squared plus 1/4 S squared cubed. Should be a negative in front, because I know the forces are going down. Now this is just simple geometry and a little bit of physics. You can do better than this. If L is much bigger than S, so if L is much bigger than S, then I can factor out I feel like I lost a square root somewhere. Just a second. R squared, denominator there. That's 3/2. Because that's r cubed. R is the square root, so yeah, this should be the 3/2. All right. So if L is much bigger than S, if I factor L out of it, I get negative Ke, big Q, little q, S over L cubed times 1 plus S squared over 4L squared to the 3/2. Well, actually, that's true regardless of that. But if this is true, then this whole term is about 1, approximately 1. Negative K, E, Q, little q, S over L cubed. So if I have a dipole, we have a net force on it. As L becomes larger and larger, this whole force becomes smaller and smaller to, at some point, we can ignore it. One other bit here. Q is half the dipole. S is the distance between them, and for a particular dipole, those two are relatively fixed. And so we can take it one step further. Negative Ke, so that force is negative Ke little q over L cubed times the dipole moment. So this P is not momentum, it is the dipole moment It is a vector, thus the symbol, that is going from the negative charge towards the positive charge. The magnitude of the dipole moment is QS. And now the tales of greatness can be shared with others. Hope you have a good afternoon, or evening, whatever this is. What is 5 o'clock? Afternoon or evening? Okay, have a good evening.
I'd say the sun would probably be more afternoon.
Yeah, I guess it does depend on where the sun is. You could begin on the master sets, for those who are not familiar with them. If you go into chapter 23, once you've done at least one attempt of the CEA, you'll find something called master set. These are old test problems, and you can, if not do all of them, you can at least start on most of them. And you also might want to take a look at the very first item should be flash quiz. Basically, it's set up, if you print it double-sided, it should line up, at least it did on my printer, and you can make flashcards. Before the actual homework quiz, there's the flash quiz. It is timed 10 minutes. That's stuff that I expect you to know cold, and it's set up so that you should be able to do flashcards on it. So, chapter 23 awaits. I will print out the lab for Wednesday, because I assume after tomorrow I will have changes to make.
See you Wednesday. Thank you.
Yep. See you Wednesday. And it is Chris, not Christopher?
Yes, Chris.
Okay. Thank you. Have a wonderful whatever time of day it is.